Friends, Prof Oza again. We are discussing the simple experiments on power system. Right now we are analyzing the short, medium and long transmission lines. As I told you, the real analysis, if you want to do, to calculate regulation, to find out efficiency, to find out sending end voltage from receiving end voltage, whatever, all analysis will be 100% correct if you go for long transmission line. That is, you consider the parameters, resistance, inductance and capacitance distributed throughout the length, say 100 km long line, throughout the length. At least you have to assume, or you have to take the resistance per kilometer, inductance per kilometer, capacitance per kilometer. But the analysis, as I was telling to you, is very complicated. And the experiment also, if we build up, then it can be built up, but costly, would require large space. Therefore, what usually people do is, people analyze the transmission line in medium wave transmission line, that is medium transmission line. Because short transmission line is only for the lines which are very short, and usually such short lines are not there. Usually the lines are 100 kilometer, 150 kilometer, 75 kilometer long. And for that you will have to simplify it. So there are three mathematical simplifications available: the end condenser method, nominal T method and nominal pi method. Mathematically, nominal pi is nearest to the correct analysis, that is nearest to the analysis which the long transmission line results in. Nominal T is not as accurate as nominal pi, but yet quite accurate. End condenser method is not at all accurate, but simplest, and therefore we started with the simplest, and now we are going to little complicated analysis, but that gives you the correct analysis of the line, and once you find that correct analysis, it would be better to design the line based on that correct analysis. Therefore, friends, to go further, motivation is the same, that we want to find out the efficiency and regulation. We want to find out the parameters. And if these parameters are not within limits as per your desire, as per your requirement of the system, you have to change the analysis and finally erect the line according to your final correct analysis. And that therefore this analysis of line is very important. It is, that is the very motivation of the experiment. The objective, once again, same. You have to find out the efficiency and regulation. Ferranti effect, which is bad, but you will have to find out, because you will have to solve the problem of Ferranti effect, that is the receiving end voltage more than the sending end voltage, when the transmission line is not loaded or lightly loaded. You have to improve the power factor at the sending end, because it is the inductance of the line is deteriorating the power factor, right? So one has to improve the power factor. And you have to find out the generalized constants as usual. Simulation is same. We are doing in single phase version in experiment. We are using 5 ohms, 2 ampere resistance, 20 ohm reactor, 1200 ohm, 5 rheostats to take different readings of load and to measure the performance on different loads of the transmission line. We use ammeters, voltmeters, wattmeters, but we calibrate them for kiloampere meter, kilovolt meter, and megawatt meter to give you a feel of transmission line. We are using 660 volt capacitor of 1 microfarad for representing the inherent capacitance of the line and also for representing the deliberate capacitance that we would want to connect at the receiving end to improve the power factor. The line capacitance, as we had discussed last time also, it is increasing the complexity of calculation. It is increasing the complexity of analysis, but it is very much required because it reduces the line current, it improves the power factor at the sending end, it improves the regulation, it increases the efficiency, line losses decrease, and receiving end voltage will be more than sending end voltage when there is no load. So that is a problem and you will have to solve that. You see, if you want to have a T analysis, then line capacitance is lumped at the center and the inductances are hard on both the sides. If you are going for pi analysis, then two capacitors, half of the capacitor, one half at the sending end, one half at the receiving end, and the total resistance and inductance at the center. That is the pi representation. Right? As we have discussed, the pi is the best mathematically as far as the analysis is concerned. Pi is like this, C by 2, C by 2. One at receiving end, one at sending end. R and X at the center. IS is the sending end current. IR is the current that is passing through load, receiving end current. But I is different because IR plus IC2 gives you I and I plus IC1 gives you IS. So all this vectorial calculation one has to do, which makes the calculation little complex. So I is IR plus IC. This is part of the figure, right? This is what we at receiving end. I is equal to IR plus IC. So IC is 90-degree leading the voltage VR. Therefore, if you calculate magnitude-wise I, the current passing through the whole of the transmission line reduces, then IR, load current. And therefore, it improves the current, it reduces the current, it reduces the line losses, it improves the power factor, right? It improves the regulation. All these advantages because of the capacitance that is there. The circuit, as I was telling to you, first we have to design the table. So as I was discussing in short transmission line, In end condenser method, we had not seen this. Here we are once again seeing this, that you have to plan a table, you have to plan a panel, you have to cut out a panel so that it looks nice to the people who come, right? When people came in accreditation and in many other committees to BVM, most of the accreditation members have appreciated Power System Laboratory. In one time, at one time, the committee took some 45 minutes in the laboratories because they were very much interested in the laboratory. They told that this is the best way in which the laboratory is prepared. And he took interest in each and every experiment. And he wanted that we should conduct some of the experiments. We conducted with him some 3 experiments. And therefore, you see, before you plan the experiment, you cannot put anywhere you like. Look, it should look nice. Therefore, the table design has to be done. That's what I was telling, that project engineering. Big project, 660 megawatt power plant is also using project engineering. That project engineering is large. Quite many things have to be done. But this is a small part. From here you will learn how to do the project engineering. The formula is simple, same. Z is equal to R plus Jx. Y by 2 is equal to J omega C by 2. IC2 is equal to VR Y by 2. IC is equal to IC2 plus IR. IS is equal to I plus IC1. So I told you. Line losses is equal to IS square R. Right. And line efficiency is WR upon WS into 100. A is equal to 1 plus YZ by 2. B is equal to Z. C is equal to Y into 1 plus YZ by 4. And D is equal to 1 plus YZ by 2. So this is what you have to calculate. And for that, these formulae are there. And as I told to you, because you are connecting capacitance, the power factor gets improved. And if the power factor is improved, you see, your MVA requirement will reduce. MVA requirement towards the sending end will reduce. MVA at receiving end is 1. At sending end, if capacitance is not there, it will be more. But here, less MVA requirement will be there. Less MVA requirement means V is constant, but A will reduce, and therefore the generator will be of smaller size. It will be less costly. Your transformer will be of smaller size. It will be less costly. So you see, whatever you do at one place, at small one place, a small capacitor that is added, is affecting the whole power system that you are using. The MVR capacity that you are using for capacitor is MVR1 minus MVR2, that is MW 10/1 minus 10/2. If you want to see the diagram, it is like this. This is VR, IR and IC, phi1, phi2. Phi2 is less, therefore power factor is improved. And for improvement of that power factor, from MVR1 to MVR2, you have to add a capacitor and you have to spend for that capacitor if you are deliberately connecting. But if the inherent capacitor itself gives you this advantage, then this is all the way better, because you see you are not spending anything and you are improving the power factor, right? So that is different. And then obviously, as you are doing in all other experiments, you will be taking readings, VR, IR, WR. Then wherever you can calculate, 1 is observed value, 2 is calculated value, right? So you will have this table. First reading will be no load reading. So you will be able to observe Faraday effect. And then you have to go on loading and you have to see the effect of loading. As you increase the load, the regulation is going to deteriorate. As you increase the load, the efficiency is going to decrease, right? And you have to see to it that at every load, the efficiency should be as small as possible. And for that, you will have to take actions. Right? You have to take action well in advance before erecting the line. Because efficiency is due to R, and R is due to dimension of the wire. R is equal to rho L by A. L is not under your control because you want to have 100 km long line means long line. That is there, right? So rho L by A, out of that A is under your control. Rho you are using the SCSR conductors, rho is not under your control. So what is under your control is A. How much thick wire you can use, right? That is under your control. That will improve the efficiency. But if you use a thick wire, then your cost of the uh, conductor will increase. Therefore, cost of the transmission line will increase. So one has to make a compromise against that. And for that compromise, there are many laws in power system which you would have studied, Kelvin's law and this and that and whatnot, right? You have studied these things. So simple circuit, once again, circuit is the same. We have drawn such a circuit, we have erected such a circuit that you can do an condenser method, you can do short transmission line, you can forget capacitor, you can use the capacitor for T configuration, you can use the capacitor for pi configuration, right? That is how we have rigged up a line. That's how we have prepared these things. And these things were done. That means right from design of the table. Table was given to the student, panel was given to the student, but panel design, then after panel design is done, then workshop people will do the holes, etc. Then once that is done, people will uh, rather insert the capacitors, etc. in the hole. And then students have connected the wires, and then students themselves have taken the readings and they have found out the uh, efficiency regulation and everything. So the students who have really designed this experiment have learned a lot. And today also they are remembering BVM because they're learning a lot. And because they are learning, now when BVM needs money, because you see government is not in a position to give money, they are only paying the staff members. So extra expenditure, we have to seek the, I mean, we have to ask to the students, the old students who have now become the CEOs, uh, the general managers, and one like Mr. Anil Nayak is more or less the owner of uh, L&T. So such people have donated lots of money because they are doing all these things because they had learned. And they had learned because they were also sincere. But then teachers also were sincere and teachers also taught them well the things. If you come to the college, college is simple because it's a government college. It is not a very modern college. It's a government college, right? The uh, the establishment, the the buildings are old, but the persons inside the building who have taught to people are very intelligent, very sincere, very hardworking, and because of their hard work, now people have learned things. So this is what we have designed, right? With that, my friends, I come to an end. When I come to an end, I always give one sentence for you. I like to read such sentences. I like to understand such sentences. I like to क्या बोलते हैं इसको digest such sentences so that our life is pleasure Our life is a pleasure. Our life is peaceful. The sentence is when you really laugh for those few moments, you are in a deep meditative state. When you are laughing, Shabuddin Rathod also told that you see, I am making people to laugh. But then when you laugh, you are not thinking. Your thinking is gone. You are thoughtless. जिसको निर्विचार अवस्था कहते हैं. People do not think. They are thoughtless. They do not have any other thought. They do not have any other worry in their mind. And for so many moments at least, they are near Buddhatva. They are near the enlightened state of mind. And if that continues longer, then the person will be enlightened for a longer duration of life, time. Therefore, it is very useful to laugh and enjoy, please. It is impossible to laugh and think together. If you try, while you are laughing sincerely, you cannot think. So in that sentence, I end my talk. When I end my talk, I always remember Adapt Me, because Adapt Me has given me chance to load so many videos, and it has given me chance to teach the people free of cost on Adapt Me, I mean on YouTube, right? So I am really very much thankful to Adapt Me. But more than me, you should be more thankful, because you are learning at no cost and you are learning to rig up the experiments. So colleges, particularly professors of the colleges, can rig up the experiments and cost is very low. And if you can teach well, then automatically the admissions will come. Now, the main problem is admissions are not there. People are not getting good admissions. But if you have good laboratories, when parents and students will uh, when they will come to your institute to see, if they see good laboratories, they would like that they send their children to your college. Therefore, don't forget Adapt Me. Not only that you don't forget, but you share Adapt Me. You tell many people that Adapt Me is helping people to learn, right? Therefore, share, subscribe, like the uh, app Adapt Me. Don't forget to thank and to remember Adapt Me. With that, thank you and good night, my friends, for the day. Thank Adapt Me. Thank Appraise.